Yesterday in class, I had given you this term. AB. What do I call AB? What do I have up on the board there? AB is called a, I'll put it back up there in a second. Not here yesterday, Jim. Natalie, what do I call AB? Oh, okay, all right. Everyone's saying that today, but it is. But remember, bisector. What's a bisector? Cuts it into two congruent parts. And you see hash marks here? No hash marks. So we got the perpendicular part, but not the bisector part. What do I call this though? This is called an, if it's just perpendicular to the opposite side. Ryan? Orthocenter is a point. This is a line. You guys, hey, altitude. This is called an altitude. Everyone good? It's called an altitude. Now, new vocab term. Instead of being perpendicular, I'm going to draw that line to the midpoint of the opposite side. And that's called a median. My diagram's a little naked right now. Because if that's a median, something's happening to BC. All right? So what I need you to do right now, if a median comes from a vertice drawn to the opposite side's midpoint, I need a couple extra markings on my diagram because it's a little blank right now. All right, so if you wouldn't mind putting a couple extra markings on my diagram showing me that AD is a median. No right angles here, right? We didn't say anything about perpendicular. That's an altitude. Medians are drawn to midpoints. All right, so conclusion, BD congruent to DC. You'll hear me say a lot, medians go to midpoints. Okay, medians go to midpoints. How many medians would be in every triangle? Not infinite. How many medians, Sully? Three, because it's got to come from a vertice. 3 vertices. All right. And I know, shocking, what you're going to figure out about all 3 of those medians, what's going to happen to them. But I'd rather you do it and see it. So down below, we're going to graph a triangle. So graph triangle ABC. And we're going to locate, we're going to draw in all 3 medians in a second. Just go ahead and get it graphed for me. All right, we're going to find the median. We're going to draw in the medians. Before we can do that, though, I know medians go to midpoints. I need to find the midpoint of each side so I can draw it in from the opposite vertice. Can we make our lives easier? Can we just do find the midpoint of CB without using the formula? I think we can do that without using the formula, right? It's a length of 4, so go 2 units from either B or C, and you got the midpoint. And then go ahead, draw using a straight edge, draw in the median from vertice A down to BC. There's 1 median. Sully said there's 3. I want to see the other 2 of them. Okay, draw in the other 2. So what we're going to have to do first, or you guys are, I'm going to come around and watch it. Find the midpoint of AC, draw in the median. Find the midpoint of AB, draw in the median. And then hopefully if you're using a straight edge, you'll notice something that's been a common theme in this unit. Medians. Yeah, that darn midpoint formula we used last week. Or used on Friday, I think. Yeah, Yeah, he's not writing it on the board.
So the midpoint on that slide. Midpoint. Add your x's divided by 2, add your y's divided by 2.
As some of you are drawing in your final median here, hopefully you notice something about all three that's been common with altitudes, angle bisectors, and perpendicular bisectors. Add your x's, divide by 2. Add your y's, divide by 2. It's a point, right? It's a point. Add your x's, divide by 2. Add your y's, divide by 2. Okay, guys, we got to move on here. When you draw all three medians in, what are we noticing? Just like Friday, our perpendicular bisectors all met at the same point. And yesterday, our angle bisectors and our altitudes all met at the same point. Well, now, there's a fourth set of lines that all meet at the same point, and that's your medians. Right? And here are the four sets of lines that you're responsible for Monday's quiz. Right? Perpendicular bisectors, angle bisectors, altitudes, and medians all meet at the same point. You ready for the name of this point? Anybody want to try to pronounce it there? Where all three medians intersect? Try it out, Max. Centroid, yes, the centroid. That is the point of intersection of all three. What did we just graph right here? What did we just graph? We just graphed three what here, Riley?
Midpoints.
We did, but then when we drew it in, what were the actual line segments called? Medians. All three medians. So you have circumcenter, incenter, orthocenter, centroid now. And those are the 4 points of concurrency we're going to go over. And let's go back to the board. Quick recap of everything. Quick recap. Circumcenter. What's so great about it? What's so great about it? What's the special fact about a circumcenter? Sully?
It's equidistant from all the vertices.
Same distance from the vertices. Incenter yesterday. Same distance from the cam. Sides. Orthocenter. Nothing special about it, but if it's in an acute triangle, where is it? Inside. Right triangle. On it. Obtuse. Outside it. All right, everyone ready for the big centroid fact? Here it is. Centroid fact. Woo! Centroid splits any median into a ratio of 2 to 1. And I will explain what the heck that means here in a minute. So wherever the centroid is, it splits its median up into a ratio of 2 to 1. Go back to your graph. Put a point where your centroid is, please. Put a point where the centroid is. Here's what I mean by it splits any median into a ratio of 2 to 1. Here's what I mean. Hopefully somebody can count in here. Hopefully we can count. Natalie, hopefully you can count. Do you see this vertex A? What I need you to do is count the number of units from vertex A to the centroid and let me know how many units that is. 4. Yes, thank you. You can count. I love it. So that is 4 units. Everyone agree? All right, Natalie, go from the centroid now, that same median, go from the centroid to the midpoint. How many units is that? Everyone see 2 to 1 now. All right. This part from the vertex to the centroid, vertex to centroid will always be double the size of the other part. Okay, always double the size of the other part of the median. Good? Questions there? Also, you're in what class? So I'll give you a little follow-up here. I wish we had more time in class and we're on such a time crunch. But also the centroid, if I gave everybody a pair of scissors right now and you cut out triangle ABC and you had a very, very sharp pencil tip and put the centroid right on that pencil tip, it would balance perfectly your triangle. It's called the center of gravity as well. Center of gravity. So if you put that centroid right on the pencil tip, that thing would just balance. Anywhere else, it would tip over. But right on the centroid, it balances perfectly. How about that? 2 to 1. And everyone always asks, question is, which one's the bigger part? The bigger part is always from the vertex to the centroid. Okay, that is always the bigger one. From the vertex to the centroid is the double piece. Okay? Questions before we start applying it? All right, let's apply it. Okay, number 4, M is the centroid. All right, everybody stop. I don't care what the rest of it says. Here's where the mindset's got to go. M is the centroid. Centroid is where all the what intersect? What are you thinking about when you hear centroid? What lines all intersect, Max? Medians. So on your diagram, guys, you have 3 medians working right now. WX, YO, and ZR. So now you say, all right, if they're medians go to midpoints. I should see hash marks lighting up your diagrams right now because you know that's a centroid, which leads to medians. There should be hash marks all around your diagram right now if those 3 line segments are medians. I don't know if I'll need it, but at least we can mark it. That's what I should be able to mark right now if I know my vocab. No right angles. They just go to the midpoints. All good. All right, now let's keep reading. WM is a length of 16. WM, 16. How about WX, the whole median? How long is the whole median here? All right, no Pythag. No Pythag here because I don't have right triangles. But I can use my new centroid theorem. which says the centroid breaks any median into a ratio of 2 to 1. I don't find Wx unless I know Mx first. All right, so can I ask somebody how long Mx is, and then I'll get to Wx. So Mx, I got 16 here already. What about the other side now? Julia?
MX equals
8, right? Again, the bigger part is always centroid to vertice. That's the double part. So that's 8, and now I can answer the question, which is Wx. 16 and 8. How long is the whole thing there? Maddie, over to you. Yeah, you can. Is that a question or 24? Good. I know I didn't use your calc there, so you're like, did I get it right? Questions? Everyone see the 2 to 1 now working? Oh, you haven't seen anything yet. Next one, ym now. Ym, length of 12. I want you to find yo and mo. Well, we ain't getting yo until we get mo, so I'll start with mo. And ym is 12. How about om? Oh, somebody's popular today. Give me a break. Assad, how long is mo?
8.
How long?
8.
Mo?
12.
Well, that's 12. And remember, it's 2 to 1, right?
Okay,
24. Good. That's 24. Any questions on how we know it's 24? Remember, that piece from the vertice to the centroid is always the double part, the bigger one. And then put the two together. Yo. Got 24, 12. How long is the whole piece? Whole piece, how long do I have there, Sophia?
36.
36. Good job. Okay, usually kids are happy when they do numbers, but now I'm going to throw x's in here, and we'll see if we really understand this centroid theorem. As I read, I'm told AD, BE, and CF are all medians. Phew, 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 phew. That's you guys putting hash marks on your diagram that quickly. All right, that's what I just did there, because you know all three of those are medians. Again, mark your diagram. I don't know if I'll need to use this, but it's true. Medians go to midpoints. And can I get a name for G? If those are medians all intersecting at G, can I get a name for G? Because it's not up here. Assad, what's the name for point G? That's the centroid. Good. Now I'm like, okay, centroid splits it into a ratio of 2 to 1. I haven't even labeled anything as far as x's go yet. BG, 2x plus 10. Other part of that median, 3x minus 1. G is the centroid, splits every median into a ratio of 2 to 1. Let me write something that is incorrect up here, and I need somebody to correct it. I got a false statement right there. It is not in a ratio of 1 to 1. Somebody here, I need to correct it, please, so I can solve it. Nobody is solving this for x. All good? They're not congruent to each other. It's not a ratio of 1 to 1, it's 2 to 1. So correct it for me, because there's two different ways you could correct it. Going back up. Maddie, what do you want me to do?
You could put the 3x minus 1 and times it by 2.
I like that. I could also put parentheses around 2x plus 10 and put a 1/2 out there. Your call. But yes, vertice to centroid is equal to double the other part. Yes, Sully.
Can you also just set it equal to half of BG?
Well, that's what I'm saying. Take 1/2, which would have been x plus 5. Yeah. You could do 1/2 of this equals 3x minus 1. Yep. Okay, go ahead. X doesn't make you a winner. I'm looking for BE here. Looking for BE.
Bigger part. Yeah, you double the time.
Should get x equals 3, so you know you're on the right track, but I am looking for the length of the entire median there, BE. Okay, BE when you have it. Oh, one more up. Sophia, when you have BE. 20, I believe so. Gotta get on the right page here. 24 it is, yeah. Questions from you guys? All right, guys, I have given you all the vocab I can for this unit now. You have everything you have, or I can provide. Next up now, it's fun for me, it's probably going to be painful for a few of you, is where do I stand? Do I have a lot of work to go before I take Monday's quiz? I think I'm picking this up. I just need to dust off some cobwebs, or I'm at the top of my game and I know this vocab down cold. We'll see where we fit in. Number 4, this is not multiple choice. For every diagram, does everyone see a segment in there called CD? I want to know, what do you call CD in the diagram? And here are your options. The 4 that we've talked about over the last 3 class days. Is CD a perpendicular bisector based on the markings? Is it an angle bisector based on the markings? Is it an altitude, or is it a median? Not possible is not an option. It's one of the 4. Okay, so I want you to go through. Hey, you can speak with people around you. We're just saying a quiz or a test. All right, talk with people around you. And then in about 2 minutes, we'll come back and you let me know your best name for line segment CD in each diagram based on what I gave you. So go ahead. What is it? You only have 4 options. Talk it over with each other. Just based off the markings. You can't put any on yourself.
How is that perpendicular?
Oh, yeah, you're right.
But then I don't understand how.
Well, there
This
could be
is how
two.
writing
things.
But is it like every
This
one?
is writing
Like
with
there's
the
only
same
one of each?
hash.
Correct. No. This is in process of elimination here. One could double up. Yes.
So,
Okay, this is not process of elimination, guys. It's not one of each. You give me the best name.
because it's just like the same thing.
One may not be used. One may be used twice. Okay, finishing up. All right, here we go. Give me the best name here. For some reason, I thought D was the toughest one out of all of these, but for some reason, A has been the struggle for many students. Part A has been a struggle. Okay, what is CD in Part A? What is CD in Part A? What do you think here, Jalen? That's a what? Yeah, it is not. I get perpendicular bisector. Remember, if you're going to tell me bisector, better have hash marks on it then. This just has a right angle. Good job. Way to go. Well, that's only an altitude. Altitudes form right angles, and that's it. That is it. How about for part B? What's CD there? What did I draw in there? Ooh, let's try that again. There we go. Cam, what did I draw in? Median, yep. I didn't put hash marks, but since I told you they were 2 inches, they have to be congruent. How about part C? What's CD in that case? That is a, Isabella? Angle bisector. They're both 28. Good. I don't need arc marks. And again, I don't know. I thought this one might have been the toughest, but we'll see. C, D. What is that bad boy right there? That's a what? Shroom, Sophia? Yeah, it's an altitude. It's an altitude for an obtuse triangle. All right, that's an altitude for an obtuse triangle. Perfect. All right, there's one step. Next one is, can you identify what the point of concurrency is? So now in the next six, I don't know how many there are. It's either going to be a circumcenter, in-center, orthocenter, or centroid. Okay, I'll do part A with you so you understand what's going on. For part A, based on my markings, what are those 3 lines? Let's start there. It's kind of like the last problem. What are those 3 lines that all intersect at that point called? I don't want the point. What are those lines based on the congruent marks? Those three are all called what? Those are three, Max. Okay, so now I go, they're medians, and I just learned that medians all intersect at the Julia, where they all intersect? The centroid. Okay, so finish up through F. See if you can name that point of concurrency.
What is it? Is it angle bisector in centers or ortho centers?
Well, for orthocenter, they have to be like the altitudes and altitudes have to have one angle. So I got for the
That's
I didn't know
Is
this
that in the
because like it doesn't have the mark.
Good. We're struggling with one of them, which is what I wanted to see.
So what was the next page?
Glad you're
That's
struggling
the
with one of
thing.
them.
This isn't
Ortho center.
because it's like outside of
And that one.
So is this also an orthocenter? Because
Yeah.
well,
Could that also be a circumcenter?
it
No, because doesn't divide depends. I think that's another ortho center.
yeah. Well, actually, no. I think would this one be a perpendicular bisector and therefore a circumcenter?
Yeah.
Is that?
That is a
Size it.
This
I
is
didn't
just showing it's
realize
coming
that
from here
when
and then
I
extending
get-
out.
Yeah.
So this is a full one right
It's
here.
coming from.
Yes.
Oh, I never seen that.
All right, what do you say here?
Well,
See
what's
if
this?
No idea.
Wait,
Would this somehow-
which one had equals? Which one had
ready. Part B. What am I showing here? What point am I showing in part B here? Choom, one up. Jalen, what am I showing? In center, because those are all angle bisectors. Good. I loved seeing you guys struggle with C. I love C. Here's why. Because if you just look at those lines, you're like, all right, those are not perpendicular bisectors. I don't, no. Angle bisectors. I don't see any arc marks. Altitudes. I don't see any right angles. They're not medians because they're not drawn to the midpoints. So he didn't give me much. But you know what I gave you? I gave you the fact about the point I'm looking for. I gave you the fact. Look at this point right here. Isn't it the same distance from all three vertices? That's what I'm showing. I'm not showing one of the special lines. I'm showing you the fact. And which point is equal distant away from all three vertices? It's the circumcenter, yes. So I didn't give you the lines. I gave you the fact instead. Nasty, nasty. Okay, what am I showing you here in D here? D is the what? Choom, Assad, that's it. Circumcenter. Oh, I need this then. If that's the circumcenter, I would need that. It's the orthocenter. Yep, that is the orthocenter. Those are all altitudes. Question so far, orthocenter. All right, and then the final couple here. Ooh, E, that's a lot going on there. That's intimidating, that diagram, but it gives us everything we need. What's that point there? What do we have, Cam? Those are all, hey, all three lines are perpendicular bisectors. Perpendicular bisects. Perpendicular bisects. Circumcenter. And then how about F? Looks like I got a couple lines we're familiar with there. What's that point in there? One behind now. We don't have one of those, but we do have, hi, Isabella. Orthocenter. Those are all altitudes. Yep, altitudes form right angles. Okay. A lot of info, I know. All right, as you guys start the homework, first thing you're going to do on the homework is fill in the chart tonight. This is like a little quick cheat sheet of all the lines, points, and facts. So I'll do the first one with you. Perpendicular bisector. In your own words, you're going to describe what a perpendicular bisector is. So let's go in our own words right now. Let's start with the perpendicular part. It's got to do what? Form a right angle. So forms a right angle. And we got to do the and here, right? Forms a right angle. And let's do the bisector. What's it? Splits us and splits a side into two congruent parts. Fine. Am I really going to test you on the definition? No. But the next three I am. Can you draw it? Can you start with the triangle? All your pictures should start with the triangle because that's what we're working in this unit. Start with the triangle and give me a perpendicular bisector with the correct markings. So you should have something that is perpendicular with a right angle and hash marks. All right, hash marks. Also, too, F honors kids, perpendicular bisectors do not have to come from a vertex. That's the only one that does not come from a vertex. I don't know if anybody noticed. None of these three came from a vertex. Okay, it's just got to be perpendicular and bisect. It does not have to come from a vertex. If you drew all three in, what would the point of concurrency be called? Circumcenter. And what's the special property of a circumcenter? Equidistant from vertices. There you go. And then you guys take the lead on the remaining three.